Hello and welcome to this video. So in the last video on operators, you saw that most of the operators weren't successful unless the different values they were operating on had the same data type. And so in this video, we are going to talk about a mechanism called typecasting. And what typecasting does for us is it enables us to convert a variable from one data type to another so that these operators that we have seen already can successfully work on them. And one thing that I want you to note, which is peculiar to Rust, is that there is no provision for implicit type conversion. So if you're familiar with other programming languages, you can see that for some programming languages, it's not a problem when you are adding a float to an integer because the compiler or the interpreter, depending on whichever language you're using, can implicitly convert one type to the other and make the operation successful. But Rust, being a systems programming language, takes safety serious, and so it doesn't do implicit conversion for you. You have to explicitly do your own conversions. And so it provides the keyword as, which is AS, that we can use to perform implicit conversions. And another thing that I want you to note is that if you convert from a data type of higher precision to a lower one, then there are chances that you will lose or you will lose some aspect of the value in that variable, or there is something known as truncation, and you will see an example very soon. So what I have here are codes that I've commented out, and I'm going to uncomment them. And already you see that there are errors in there. And now I'm going to explain why there are errors in there. So you can see that int s has been defined to have the data type i32, and int y has been defined to have the data type i64. And you might be thinking, shouldn't it be possible for the addition operator to work successfully on these two types since they are both integers? And the answer that Rust gives you is no. And the reason why it is no is because it is no. The plus operator wants to operate on operands that have the same data type. And so at this point, we have to cast one of the values to the data type of the other so that the operator can work. So over here, you can see that S is i32 and Y is i64. And so what I can do is I can either cast S to i64 like this, so that S is now i64 and Y is also i64, and you can see that the answer is 25 and is working as expected. And because I casted int x to i64 and Y is also i64, the resulting answer is i64. Another thing we could have done was, instead of casting S to i64, we could also cast Y to i32, like I'm doing here. And so the result is also going to be an i32 because it is an operation that is happening on two i32s. Okay, the next thing I want us to look at here is between floats. So you can see that I have float S, and that is f32, and I also have int y, which is i32, and I'm trying to perform a division between the float and the int, and you can see that this is also impossible. Okay, and so we have to use the as keyword to convert one to the type of the other, but which one you convert depends on what you want to do, because if I convert this float into an integer, I'm going to lose all the values that comes after the decimal point. That is what is known as truncation. And because that is not what I want to do here, I actually want to divide 72.675 by 10. What I will end up doing is I'll have to cast the integer into an f32. And so what I'm going to do here is I'll just say as f32. And now this is an operation that will succeed. So I go ahead and I run, and you can see that now I can divide 72.675 by 10, and I get my answer, which is also an f32. The last thing I want us to look at here is when you convert between a float into an integer. So let me remove this and you will see the error. So basically I have float s, which stores the value of pi, which is 3.142, and I'm trying to fit that into an I32. And you can already see that it is impossible because the integer has no capability to represent what comes after the decimal point. And so the reason why type conversion is important is because of how these different data types are laid out in memory and the capabilities of each of the data types. So you can see that F32 is able to store something that comes after the decimal point, but an integer cannot do that. So if I try to put the value of an integer, the value of a float 32 into an integer, it's not going to work. And so what I have to do is to cast the float into an I32 so that it matches. But what is going to happen here is I'm going to lose precision. I'm going to lose some of the values from float s. So let's come here and do cargo run. And you can see that when I converted 3.142 from a float 32 into an integer, the result was 3. So we lost the 0.142, which is also known as truncation. So thank you very much for watching this video, and I'll see you in the next.